Question number 14 here, and we have a question all to do with polygons. So the information here is really important, and the first kind of key word that we need to tease out is that the polygons we're talking about are regular. And we remind ourselves that regular means that all of the sides are the same length, but importantly for this question, all of the angles are the same size. The larger polygon around the outside here is an octagon, which is an 8-sided shape, and the two ones that are constructed internally are pentagons, which are 5-sided shapes. We're then asked to calculate angle x here, which nestles in between these two pentagons. So there are many ways to approach this question. The way that I'm going to approach it is to first of all think about the construction of this angle here, which is the interior angle of the regular octagon. Our rule about finding interior angles is that we're going to take the number of sides minus 2, because that tells us how many triangles can be formed inside any polygon, and we're going to multiply that figure by 180 because we know the angles in any triangle total 180 degrees. So for an octagon we have 8 take 2, which is 6, and then 6 lots of 180, which is 1080 degrees. That gives us the total angles of all of the 8 angles inside, so the total for all 8 angles inside the octagon. So if I want to find one of them, which is what I marked here at angle FER, I'm going to divide this figure by 8, and I know that that's going to give me 135 degrees. What we can then go on to see is we also have just here the angle inside a regular pentagon. So using the same rule, number of sides for a pentagon is 5, subtract 2 is 3, 3 lots of 180 is 540, and then to find one of them, 540 divided by 5 is 108 degrees. We now have to think about why this information is important, because what we have here between F, Q and E is a triangle, but not any triangle, but an isosceles triangle. And I know it's isosceles because this side here FQ and this side here QE are both coming off of the regular pentagon, so they have to be equal in length. What I can now do then is, if I can work out the angle inside here, which is going to be the difference between the 135 degree octagon interior angle and the 108 degree pentagon interior angle, I'm going to be able to find the remainder, which is the portion inside here. So this is now 27 degrees. If this is 27, then I know that this is also 27, and I then have finally my isosceles triangle with two known angles, and the third one that I'm being asked to find, which is angle x. So 180, subtract 2 lots of 27, which is 54, so 180 subtract 54, let's do that now. Angle x is 126 degrees.